Welcome to the NXP's NPIC Shift Register-based LED Drivers Product Training Module. This presentation will introduce the use of shift registers in input-output expansion applications such as LED driving. In addition, this presentation will provide an overview of NXP's NPIC Shift Register-based LED drivers, how they are used within applications, their features, and the benefit of designing with NPIC shift register-based LED drivers. Many applications use single or multiple LEDs. These include 7-segment displays and single indicators, as well as an array of LEDs that form grids or panels. To drive these LEDs, 5-volt serial input parallel output shift registers are commonly used. Solutions such as the 74HC595 are used as input-output expansion. They allow a microcontroller to control 8 LEDs using 3 of its control pins. Serial data is applied to the serial input of the shift register and clocked in via the input clock. Once the 8-bit shift register is loaded, the output clock applies the data to the storage register and the outputs. External drivers controlled by the 74HC595 then activate the corresponding LEDs. The use of shift registers as input-output expansion allows the selection of lower pin count and thus lower cost microcontrollers. They can reduce the total number of controllers required. A further advantage of the 74HC595 is that it also includes a serial output. This feature allows several devices to be cascaded together. Now the same 3 microcontroller pins that were controlling 8 LEDs can be used to control 16 or 24 LEDs. In some cases, the 74HC595 can be used to drive LEDs directly. For applications that drive the LEDs with voltages higher than 6 volts or ground current that exceeds 70 milliamp, external drivers are required. The NPIC 6C596 is an integration of a shift register and external drivers. This integration allows significant bill of material reduction as the device can drive the LEDs directly. NPIC 6C devices have 33-volt tolerant open drain outputs. Each output is designed to sink 100 milliamps, and there is no ground current limit. All outputs can actively sink 100 milliamps at the same time. Outputs include current limiting circuitry, which limits the maximum current each can sink. They also include thermal protection. The open drain outputs include current limiting circuitry, which limits the maximum current each output can sink. As the drain voltage increases, the drain source current decreases. This feature protects the outputs and the components they are driving. At 25 degrees C, the output clamp is typically activated when the drain source current is 250 milliamps. Thermal protection is also included in the open drain outputs. As the temperature increases, the output resistance increases, limiting drain source current to prevent damage to the output and the components it is driving. At 25 degrees C, the output typically limits the drain source current to 120 milliamps. The NPIC 6C595, NPIC 6C596, and the NPIC 6C596A are 8-bit solutions, and NPIC 6C4894 is a 12-bit solution. All of them include a serial output for cascading. Data is propagated through the shift register on the rising edge of input clock. For the NPIC 6C595 and NPIC 6C4894, the same rising edge is used to clock data to the serial output QS. The NPIC 6C596 and the NPIC 596A delay the serial output to the next falling edge of the input clock. This delay provides a longer data hold time when cascading shift registers. A longer hold time improves timing margin and facilitates the cascading of many shift registers. The NPIC 6C596 and NPIC 6C4894 can be used between 4.5 and 5.5 volts, making them suitable for 5-volt control logic interfaces. The NPIC 6C596A can be used from 2.3 volts to 5.5 volts, making suitable for 5-volt, 3.3 volt, and 2.5 volt control logic interfaces. NPIC 6C LED drivers are available in industry-standard SO and TSOP packages, as well as the space-saving DQFN leadless package. DQFN packages are up to 76% smaller than TSOP and 40% smaller than QFN. They include a heatsink and are the package of choice for higher current or space-constrained applications. In summary, NXP continues to drive innovation in the logic market with the release of NPIC shift register-based LED drivers. NPIC shift register-based LED drivers are available today from NXP to help reduce the bill of materials of your display application.